Okay, so using your knowledge of aspartyl proteases, develop a plausible explanation for why protein activity changes when pH is increased or decreased from pH 4 as shown in the graph. Okay, so right here we have activity, right? And you notice that pH 4 it works quite well. It has good activity. But when we get too much below pH 4, it drops off. Well, it doesn't drop off that much at, 3.5, but by 3, it's completely dropped off, right? And then it slowly drops off from pH 4 down up to pH 7, right? So we need to go through and figure out, well, what are the things that are likely true here? And by extension, then we would say what's false, right? Okay. So, which statements are true? Both ASP side chains are deprotonated at higher pH value. Okay, so first off, wouldn't ASP side chain be deprotonated at higher pH values? Yeah. Yeah, they could be deprotonated, right? As you go up in pH, they'd be deprotonated. If it folds correctly under these normal at pH 4, then them being deprotonated at higher pHs is going to cause them to change structure, right? And that will change the activity, making it, in this case, worse. That makes sense. The protein is active when one ASP residue is protonated and the other is deprotonated. Okay, so we need to think about that a little bit. So if it was okay that they're all just protonated, then it would make sense that when this pH gets lower, you wouldn't see a rapid drop-off, right? But we do, don't we? And notice that when you are getting here, you actually have a fairly low drop-off here, don't you? And one of the reasons for that is when you're going from in these pH ranges, you may remember this from like your titrations and stuff. It's not like you go directly from one to the other species 100%. That's it, right? You slowly change over species and start protonating those species, right? Or deprotonating them in this case, okay? Does that make sense? So you can kind of see that here a little bit. That when you get them both deprotonated completely, or both protonated completely, it just kills the activity, right? When you start deprotonating them, well, your species, you're starting to deprotonate more and more of that primary one, the one that's supposed to be protonated, but you still are, it's not like you get 100% the first time. Killing it off slowly. Another thing that's interesting to me is these are factor 10 changes. So in biology, this is something people don't understand. Unless you have a factor 10 change, there really isn't much difference in binding or infection or disease outcomes or any of these things unless you have factor 10 changes. So like the difference between 15 and 10 times is there's very little difference. The difference between doubling or tripling something, there really is very little difference, actually. It's not until you get 10, 100, 1,000 times that you start getting really real differences. So like that COVID vaccine stuff, you get double the outcome. Double the binding. Is double the binding even meaningful? No. Like a 10 times binding would be a factor 1 difference, right? You might get some change. Double. So silly. Only one ASP side chain is protonated at low pH. So these are actually counterpoints, right? Both cannot be true. So if this one's true, this one cannot be true, right? So, well, we see here that the activity drops off beyond 3.5 drastically, right? So that means they have to both be protonated at that point because it's just killing your structure. Kills your activity. Active aspartyl proteases have only one ASP residue in the active site. That one you'd actually have to remember what these look like, okay? So you'd have to look up what it looks like and say, does that have one or two in there, right? If you look in your book, you'll see that there's two in there. One's protonated, one's deprotonated, right? Both ASP residues are protonated at more basic pH values. Does anything about that make any sense? No. More basic pH would give you deprotonated, right? The whole sentence doesn't make sense. Okay. Does anybody have any questions about that? Do I have the figure in here? Probably not. No, doesn't look like I do. Okay. Anyways, you can look it up in your book. If you need me to look it up or you don't understand something, let me know. Anybody confused? Did I lose anybody?